So we're doing slope fields today. Now, slope fields looks hard. It looks hard, but it actually is one of the easier topics. Now, it looks hard because of all the designs and all that, but you're going to see it's not that bad. And in a little bit, we'll see if I can log into Delta Math, and you can see like all the little cool, like you don't have to be perfect when you're doing the drawings. It just has to more or less, like it's very, well, you'll see. All right, let's do number one together. So it says dy dx equals x plus 1. So what you're going to do, they're usually called lattice points or little tiny slope segments. What you're going to do is you're going to draw slopes at each little lattice point. These are called lattice points, but you don't have to worry about technicalities. So notice that dy dx, that means slope, right, is only influenced by the x variable, x plus 1. So the y never affects it. Does that make sense to you guys? Okay, so then I'm just going to start at the origin. So on the x-axis, at the origin, the x value is 0. 0 plus 1 is 1. So make a little slope field of 1, like a little segment of 1. Chavez, how do you tell what's a slope of 1? Well, follow, that other point over there, 1, 1. So that's a slope of 1. Do you see that, guys? And right on the y-axis, I can do all of them are slope fields of 1. So on this one, I'm going to put slope 1, 1, 1, 1, because it's not affected by the y value. The x value is always 0 there. Does that make sense? All right, now let me go ahead and, this is the most important one that we got to make sure it looks like it. When x is negative 1, what is negative 1 plus 1? 0. So at x equals negative 1, make sure those slopes look like 0. So 0, 0, 0, 0, 0. Do you guys see how we did it? Now when x is negative 2, what's negative 2 plus 1? Negative 1. So make it look like a negative 1. Negative 1, negative 1, negative 1, negative 1, negative 1. And then when x is negative 3 plus 1? Negative 2. And you might have, well, there it is. Negative 2. It's aiming towards this one for a slope of 2, right? Negative 2, negative 2, negative 2, negative 2. Make it look steeper than the previous one. All right, let's keep going. I'm at x equals 1 now. What is 1 plus 1? So 2, 2, 2. I know you don't have a reference on some of them, but it's okay. At x equals 3. 3 plus 1. 4. So make it look steeper. It's almost vertical, but not quite the way it looks. At x equals 5. 1, 2. Actually, 1, 2, 3. I'm at 3 now here. 3 plus 1 is 4. My bad. It was okay. Just make it look steeper than before, which it does. Sorry, guys. I think I messed up with my words, but you guys know what I meant. And there it is. Cool or not cool? Notice we're supposed to, don't draw this part. I'm just going to say something random. If I draw a point right here, how would this curve look? Yeah, it would look like a parabola. It would look something like, and you just follow the wind. It will look like that particular slope. Do you guys see that? So pretend these are like wind lines or something, like where do I go? And then you just follow the wind. So when you get your Delta Math, it's going to ask you to draw slope fields. It's easier if you have a mouse, because if you try to draw your slope field with a little mouse pad, you're probably going to get a lot of errors because, the sensitivity of it. So it's easier if you have a mouse. Or maybe if you have a touchscreen, it's probably easier with your finger. But there it is. That's how we do it. Let's go to number 2. This one says 2y. So it's not affected by x's. It's just affected by y. So on the x-axis, the y value is 0. 2 times 0 is? So make lines of 0 right here. It's not affected by the x value. It's only affected by the y value. So for this one. For that one. So on the x-axis, the y value is always 0. So the x-axis should have 0 slopes like that. At y equals 1, my slopes are going to be 2. They don't have to be perfect. Let's see, that's 1, that's 2. 2. Trying to make a slope of 2 there. Slope of 2. 1, 1, 2. 2, 2, 2. And then at y equals 3, my slopes are going to be 6. So just make it look steeper than the one below. Oh yeah, 4. Just make it look steeper. Man, I don't know what's wrong with me today. It's probably lack of sleep. Actually, I went to sleep early. but I ate pizza and it kept me awake. I'm making all these excuses and none of them are excuses. All right. At y equals -1, my slopes are -2. So make it look negative, guys. -2, -2, -2. And then at y equals -2, my slopes are -4. So I said it right this time. Make it look more negative, so steeper. And there it is. If you're worried about how they're going to be tested on the exam, they're not going to have a ruler and be like, oh, is this really 2? Let's check. What they're going to check, if the slopes are 0, they're going to check. It better be horizontal. And then if you have like one that's a slope of 1 and one that's a slope of 3, they're just going to see, is the one at 3, that's the one that's supposed to have a slope of 3, does it look steeper than the one that's a slope of 1? Does that make sense? So you don't have to be perfect. You just got to make sure that relative to the other slopes of steepness, that they're all more or less related. Don't make a slope of 1 look like a slope of 5.
So these do show up on first one.
Oh yeah.
You're gonna. One it showed up on.
You'll see, yeah. Well, everything's fair game, right? As long as it's calculus. So you're gonna see. We're gonna show you a free response right now. Well, not right now, but all right. So these x plus y, they look more complicated, guys. But if you start looking at the big picture, they're not really. And this slope field really doesn't help you much, but that's fine. So here's how I would do it. I would look at first where is this slope 0? Well, this slope is going to be 0 wherever y equals -x, right? If y and x are opposite of each other, you add them up, it's going to be 0. So where does that happen? At 1, -1, at 2, -2, at 3, -3, at -1, 1. Does that make sense to you guys? So here we go. So 0, and then -1, 1, 0, -2, 2, 0, 1, -1, 0, 2, -1, 2, -2, 0. So there it is. All along those lines, I'm going to have slopes of zeros. What's up? Yes. Do you see this point that I'm circling? That point is 1, -1. If I plug that x value in here and this y value in here, what is 1 plus a -1? And that's what, there it is. That's my slope. That's how I would do it. Yeah, no problem. And then what I would do next, I think I would probably do like have one variable constant while one moves. Does that make sense? So I think I would do either the x-axis or the y-axis. Let's do the y-axis. I'm at 0, 1, so that means the slope has to be 1. I'm at 0, 2, so that means my slope has to be 2. And then I'm going to go right here at 0, -1, so that means my slope has to be -1. Bless you. 0, -2, my slope has to be -2. Does that make sense? And then I start thinking about this line here. Well, I still got to do the x-axis. Let me do the x-axis before I do that next line. All right, x-axis. I'm at 1, 0, so that has to be a slope of 1. 2, 0, slope of 2. 3, 0, slope of 3. -1, 0, slope of -1. -2, 0, slope of -2. -3, 0, slope of -3. And you see these right here? I'm going to circle them in blue. Those are slopes of -1, right? I bet you this one over here is also going to be a slope of -1. -3, what's that, 1? Oh, yeah, -2, 1. -2 plus 1, -1. Do you guys see that? So this one, so it looks like that. Okay, and now don't worry, we're gonna fill it all in. Here's what I want you to observe. Observe everything to the right or above the slopes of y equals 0 is gonna be positive slopes. And everything to the slopes of, everything below the slopes of the 0 are gonna be negative slopes. So there it is, and you can just go a point at a time. You don't have to go all crazy, guys. You can pick one value to be constant and just go right up and down that line. So let's go to x equals 1. So 1, 0, 1. And then I go to 1, 1. What's 1 plus 1? 2. So make it look like 2. And then I go to 1, 3. What's 1 plus 3? Oh, actually, that's a 1, 2, right? 1, 2. What's 1, 2? 3. So there it is. And then I just keep going. I already got all of x equals 1. Now let's go to x equals 2. So 2, 0 is 2. 2, 1 is 3. So make it look like a 3. And then 2, 2 is 4. Make it look steeper than, there it is. See? Now I'm going to 1, 2, 3, 0. 3, 0 is 3. It's already there. 3, 1 is 4. So make it look like the previous one you just did. And then that's super. So the steepest one is this one. Steepest. On that quadrant. Do you guys see how we did it? And you're just going to keep going. Okay, now let's just go below there. So I'm at 3, negative 1. So that's going to be 2. So make it look like a 2. And then 3, negative 2. So make it look like a 1. There it is. And it looks like I have one little pixel, one little lattice point that I haven't done. 1, what's that? 2, 1, 3. See? And we're just doing a point at a time, guys. Oh, 2, negative 1, 1. My bad. 2, negative 1, 1. There we go. And then let's see. So negative 1, I have one little pixel up there or lattice point that I haven't done. Negative 1, 2, so that's 1. And I got one over here that I haven't done. 1, 2, 3, negative 3, 1. That's negative 2. So negative 2. That's negative 1, negative 2. Negative. Okay, there we go. And there it is. Now we just need one more quadrant. Let's see. Negative 1, negative 1. That's negative 2. And then negative 3 if I go down another. So now negative 2, negative 1. That's negative 3. And then negative 4. So more steeper. And then negative 3, negative 1. That's negative. Oh, actually, negative 1, 2, 3. Yeah, negative 4, negative 5. So this is the most steepest in negative. And there it is. That's how it looks. Yes.
How will we determine which is more secret than the other? Because some of them kind of look the same, but I know in my head that it's
Well, this is way too many points. The way it's going to look on the real deal is like this. Look how many points they gave. So this will be obvious when it's just this. Obviously, look, on this, you have to do nothing. You just look at it. See? You just look at it. Like I can tell just by looking at it, it's going to look something like that. Or a family of a whole bunch of those. You know what I mean? And I can tell by looking at this that it's going to look something like that. You know what I mean?
Yes.
So you don't have to be perfect, guys. But I think we got the hang of it.
Yeah.
So what do you guys think? All right, so number 4, go ahead and see if you guys can do number 4 on your own real quick. It only depends on x's. It doesn't have to be perfect. It doesn't have to be perfect, guys, so don't invest, because you can lose a lot of time trying to perfect it. You don't have to perfect it. It doesn't have to be perfect. There it is. Does it look like parabolas? Then you did a good job. Because the antiderivative of 2x is x squared, so there should be a whole bunch of family of x squareds, depending on where your curve is. If your curve goes through here, then it's going to look like that. Oh, well, okay, I messed up with that part. But if your curve goes through here, then it's going to look like this. See? Cool, right? All right, y minus 1. Where are the slopes 0? Whenever y equals 1. So at the y equals 1, put slopes of 0. So you probably have a horizontal asymptote there. At y equals 2, what's 2 minus 1? So put slopes of 1 at the y equals 2. See? And then at y equals 0, so the x-axis, 0 minus 1 is, so put slopes of negative 1. At y equals negative 2, y equals negative 1, slopes of negative 2. So just make it look steeper. And then at the negative 3, make it look the steepest. And you get this illusion. Doesn't that look cool? By the way, I don't know if you guys watch the Weather Channel often. Slope fields come out so much in the weather. Do you know every meteorologist has to take Cal 1 and Cal 2? So every time you see a meteorologist on TV, they have taken calculus. For obvious reasons, because of stuff like this. So I think that's cool. So they know vector calculus if you talk to them. Hey, have you guys done vector analysis, vector calculus, differential equations? Oh yeah, we did this in undergrad, blah, blah, blah. Like, I'll tell you. All right.
So how would that look in terms of like actual lines? Like, is it?
Yeah, if I had a, let's say I had a point right there, that green one, it will probably look like, well, it looks like I'm getting more and more like steeper down here. So it'll probably look like, and then as I get closer and closer, I probably would not cross that line. It would probably be a horizontal asymptote.
Okay, and then there will be another one to
Well, if my point is down here, then I probably would not have a point up there. Like, you know what I mean? Like, it depends. Like, your solution curve is going to be different. Like, if I have a point up here, then it's probably going to look like this. And then you wouldn't have, like, it because depending on your situation, your curve can either be above that asymptote or below that asymptote. Because you're modeling something, you know what I mean? And it just depends on variables and all that other stuff. All right. Number one on number 6. Number one on number 6. Number one rule on number 6. You are undefined at x equals 0. Do you guys know that? And I know that you may be tempted to write like, oh, well, undefined slope, that means a vertical slope. So at x equals 0, I'm just going to put vertical lines. You may be tempted to, but do not write, if it's undefined, do not put anything in there. Just know that as we approach x equals 0, the y-axis in this case, just know that if we do approach it, we have a curve that approaches it, it's going to be approaching maybe a vertical asymptote, or maybe, because remember, it's possible that it's undefined at that location. If you have a vertical asymptote, the function's undefined. Does that make sense? So don't write any slopes on it. Just as we get closer to it, when you do this simulation on like Desmos or something, you'll see the slope fields as they get closer to the y-axis will get really, really close to vertical, practically vertical, but you won't see vertical lines on the slope fields. Does that make sense, guys? Now, some professors say otherwise, so whenever you get to the university, do whatever the professor tells you. But I'm just telling you what I've been taught, what I've taught, what other professors have told me who have doctorates in mathematics. They say don't draw the slope field there. And College Board will not put you in a situation where they're going to have points where they're undefined. They won't even put them in there. Now, if you put them in there, so let's just say, I'm just making this up. So let's say, look at this one. So dyd, just look, don't write anything. I know that this is undefined whenever x equals 1. Notice, at x equals 1, did they put any points? No. But if you did this, because it's undefined, undefined slope, vertical line, they're going to take away a point. Because you're not first of all, there's no lattice points there. They're only asking for your slope at these 6 points. Why are you putting more? You know what I mean? So don't do that. Okay, that's just a warning. Sorry if it came across as aggressive, guys. All right, so let's do this one. Let's be smart. Everything in quadrant 1, just look at it. Don't write anything yet. Everything in quadrant 1, is it going to be a positive slope or a negative slope? Negative. So we already have an idea more or less how it should look. Everything in quadrant 2 better be a positive. Everything in quadrant 3 better be a negative, and everything in quadrant 4 better be a positive. That's just something for you to keep in the back of your mind. How do you do it? Let's just take it a one at a time. So I am at 1, 0. So let's do the easy ones first. When y is 0. 1, 0, 0. Let's do red. 0, 0, 0, 0, 0. And be careful, don't put 1 at the origin. So I have my y-axis covered. Now I'm going to go to 1, 1. At 1, 1, the slope is -1. And now I'm going to go to 1, 2. At 1, 2, the slope is -2. There it is. I made it look steeper. I'm still at 1, at x equals 1, so I'm going to go to 1, -1. Now my slope is +1. And now I'm going to go to 1, -2. So now my slope is +2. Make it look steeper. So I got all x equals 1 done. Now I'm going to go to x equals 2. 2, 1, -2. 2, 2, -1. -2, -1. All right, 3, 1. -1/3, so just like not quite flat, but it's still negative that you can tell. Right? 3, 2, -2/3, so, and there it is. And you can kind of see more or less the shape of this. It's kind of like going down like that and up like that. It looks like it's doing this, guys, like if I have a curve. That makes sense? And it's probably going to be symmetric on all of them. So I bet you on this one it's going to be like that, and on this one's going to be like that, and on this one's going to be like that. So there it is. So now we know the basic shape, and let's just do it a point at a time. So right now I'm focused on the x equals -1s. I'm going to go up and down. What's up? Yes. 1, 2, 1. Oh, did I do it too much? I see that I had a lot of things there. 1, 2, 1. The slope to 1 needs to have a slope of half. -half. So I'm going to say -half right there. Yeah, I'm trying to see if I can tell a difference between all three of these. It looks like I'm trying to. This one looks like the steepest, and this one gets a little flatter, and this one gets a little flatter, which is supposed to happen, right? Because you get more and more to the right. So, yeah, as you move more and more to the right, they get flatter, guys, left to right. Or right to left on this one, it's going to get flatter. All right, I'm at -1, 1. What's that? +1? -1, 2. +2. -1, -1. -1. -1, -2. -2. So I got all the x equals -1 out of the way. -2, -1. I think that's the slope of half. +half. Everything in quadrant 2 is going to be positive. Oh, did I say -2, -1? Sorry. I just realized. I'm in quadrant 2. -2, +1. Sorry, miss. -2, +2. -2, +2. That's going to be a slope of 1. -3. Did I do that right? -3, +1. That's 1/3. So flat. That's the flattest one. -3, +2. That's 2/3. So it looks pretty good to me. I think I did a good job with that quadrant 2. Now I'm in quadrant 3. -2, -1. That's going to be positive, negative. Yeah, negative. Everything in quadrant 3 is negative. -2, -1 is going to be a -1/2. -2, -2 is going to be a -1. All right, -3, -1, that's -1/3. -3, -2, that's going to be -2/3. So a little steeper, but not. All right, there it is. One more. Well, I guess we still got the y-axis. We'll do it in a little bit. Actually, no, we don't. Leave it alone. 2, -1. -1/2, +1/2. 2, -2, +1. 3, -1, +1/3. 3, -2, +2/3. So this one should be flatter. There we go. I think we did an okay job. Do you guys kind of see the pattern? Yeah, it looks like if you had a curve, it would look like that. Yeah, I think. So we just did 6 examples of slope fields. That was brutal. We did a whole bunch. What do you guys think? But we got the basic idea, right? Okay, so check it out. We got some slope fields. All we're doing is matching. So let's do the easy ones in my opinion. In my opinion, the easiest one is letter A. So I'm going to rank them from easiest to hardest. Easiest, second easiest. Well, yeah, because it looks sinusoidal. Okay, so maybe you're right. All right, let's work on letter A first. Let's just go A, B, C, D. Letter A, it looks like I have 0 slopes right there. And let's look at letter A real quick. Does it look like if I go up and down, or if I go left and right, does it look like the x variable affects it? No, look at that. I'm looking at this line here. The x variable is not affecting that slope. So those slopes are only affected by y. So that one's out. That one's out. So the only one is between 7 and 9. Which one do you think? 9. And it does look like at y equals 2, it looks like that's 2, that at y equals 2, that's a slope of 0. Does that make sense to you guys? Okay, look at letter B. Letter B just looks like what? Parabola is affected by x. It doesn't look like it's affected by y's at all. So is there anything that just has x's by itself? So number 10 is B. Letter C looks like it's just going up and down, up and down, up and down, up and down. Which one does that look like? Sine. So number 7 is C. And then the last one, let's just verify. You see how we have x minus y? So I know that I have 0 slopes whenever y equals x. I'm going to put 0 slopes. This is not an equation, by the way. I'm just saying. I have 0 slopes at that line. Does it look like y equals x? Does it look like that line right there is y equals x? Yeah, it does. So there it is. Number 8 is D. Do you see how we did it, guys? All right. Now see if you guys can match that one. And then we'll verify with you guys in a little bit. Try it yourselves. Try real hard, guys. What about it?
Like the C and E in the middle are those dots? What are
Oh, they're just little pixels, like scale, the scale. I'm sorry. Potato Wait tacos, guys. Just give me 1 second. All right. You guys ready? All right, Arispe. What'd you get for number 11? Good job. Did everyone get B for number 11? All right, I'm going to call on someone, guys. No pressure, though. We're all in this together, and if you get it wrong, it's okay. Let's see. Ms. Medell, what'd you get for number 12? No, you're good, miss. You're good. Yeah. Can you tell us how you figured it out? Yeah, it looks like the x-axis is 0, or it looks like I'm flattening out. It doesn't look like I have slopes there, but that's fine. And above that, it looks like positive. Below that, it looks like negative. Yeah, it looks good to me. Taylor, what'd you get for 14? Oh, 13, sorry. Yep. How'd you figure it out? Okay. Perfect. Yeah. These look, what shape does it look like they make? Yeah, these are circles, guys. Depending on where you're at. If you're out, the further out you are, the bigger the circle. It looks like the slope field will take you out, like, you know what I mean? Cool, right? And then the last one, number 14, that one looks like letter A. Can you give me one hint on how you know besides it's the last one? Yeah, y equals negative x. What about it? That's where you have 0 slopes. Good job. Now, this is not an equation. This is not an equation for this general graph. That's just where I have 0 slopes. Okay. All right. Looks like you guys are good, guys. So do you guys want to take 2 minutes, see if you guys can figure this question out? Or 1 minute? Question 15. There's 2 answer choices that are just ridiculous. What 2 answer choices should you delete right off the bat immediately without thinking? Yeah, cosine and I think the parabola, the x squared. I don't see any parabolas in there, and I don't see this going up and down, up and down. I think I could also, if you know y equals e to the x looks like this, does that look like that? No. Y equals e to the negative x looks like this. Does that look like that? No. So it has to be ln x, and I know it's a little tricky, but if you graph ln x, it in fact does look like, and notice that they have this here, that's because you have a vertical asymptote there. So yeah, this fits ln, or a log. Correct. ln does not. Correct. Well, they have a limit of 0, but they technically do not cross the x-axis. Yes. Good job. Cool or not cool? All right, look at number 16. I think I might have given the answer away, but it's okay. I think by now you guys are semi-pros. Take 1 minute and see if you guys can figure out that one. Really, I think almost all the answer choices are silly except for one. Yeah, I don't see this going up or down, so which two do I delete immediately? Sine and cosine, they're out. Do you see parabolas? Out. Does it look like an ln? Out. This is definitely a cubic function. And it looks like a cubic. All right. What you're looking at is the question from 2016, question 4 with no calculator. Do you guys want to see if you can do letter A by yourself? Okay, take 2 minutes. So draw your little segment. I think I graded this one that year. Bless you squared, bless you cubed. Yeah, if you want to, you want to make it bigger.
Yeah, because if I put the line the wrong way, can I just I don't know how to scribble it out? Because we want to white out or pencil on it.
Well, yeah, because you have ink. Yeah, you can just, or I bet you if you wanted to, you can just even cross it out and start over. You can use pencil. Yeah, it's a person grading it, so a machine does not grade this. It's a human.
But I thought for other free response questions for other classes, you can choose, but okay.
As long as you write within, you're gonna have barcodes on the side, do not write past this line, because they scan your test. So the window that's the window that the reader is gonna see. So if you mess up, you can probably just do another sketch. You know what I mean? Or just correct it and be and then write the slope is blah, and then that way they know that it's a positive one here. To indicate the number?
Yeah.
Nah, I wouldn't. They didn't take away points though.
Like this type of thing, because I drew it the wrong way and then I just sort of scribbled it out.
Yeah, I think it'd be fine. All right, here we go. The first, I think I don't remember. I do remember, but I don't remember. I need to look at my notes. I am pretty confident that I graded this question that year, and I think this was worth 2 points. We can look it up. I can't remember where off the top I had 1 point for 0 slopes. Where do I have 0 slopes? On the x-axis, because that's where y value is 0. So you do bam and bam. Do not write anything on the 1. So I think, and then 1 point for correct slopes on the other is making sure that one's positive, one's negative. Magnitudes don't really play a case on this, or it might have, I don't remember. I'd have to look at my notes. Let's look at this one. So at 0, 1, 1 squared is 1, 0 minus 1 is negative 1, so that should be a slope of negative 1. So Chavez, how do I do a slope of negative 1? Well, here's 1, so if use that to help you out. Does that make sense? So at 0, 2, 2 squared is 4. So 4 divided by negative 1. So here's a slope of negative 4. Just make it look steeper. That makes sense? And there it is. Go to the next one, 2, 1. So let's see. 1 squared is 1, 2 minus 1 is 1. So that's going to be a slope of 1. There it is. And then 2, 2. 2 squared is 4. So make it steep. There it is, full credit. I can tell that the one above it has a slope that's steeper than that one. If you want to note somewhere that you calculated the slope, that's fine. It's not going to kill you. If you want to write dy dx at 1 comma, oh, there is no 1, at 2, 2. If you want to do that, that's fine. That's fine. I mean, it doesn't hurt. The reader is going to be like, yeah, this kid knows what they're doing. And then, you see that, and then they see this. Maybe it's even more work. Maybe it's even better because you're showing them that you know how to calculate every little lattice point. But make sure that your slope field is nice and clean, and there it is. Cool or not cool? All right. Letter B. Do you guys want to do that one, or do you guys want to do it together? Like us together? Okay, it says, let y equals f of x be a particular solution to the given differential equation with initial condition f of 2 equals 3. Write an equation for the line tangent to the graph of y equals f of x at x equals 2. Use your equation to approximate f of 2.1. Oh, I love it. Beautiful question. What do I need to get a tangent line? A slope and a point. Do I have a point? Yes, the point is 3, 3. Do I have a slope? Yes, they don't give it to you directly, but don't they give me my dy dx? So you're going to write, here's what you're probably going to write for full credit. You're going to write dy dx at 2 comma 3 equals, and then you just write 3 squared over 2 minus 1 equals 9 over 1. Sorry, guys. I don't know. I got lost in thought. Not because I don't know what 3 squared is. I was thinking of other stuff. All right, so there it is. My slope is 9. My point is 2, 3. So here's my tangent line. Y minus 3 equals 9, parenthesis, x minus 2. And they want me to use this to approximate what? F of 2.1. So get this to be like y equals something, and then we're going to write it as f of 2.1 is approximate. So, yes. Oh, well, they told me. Write an equation right here. For the line tangent to the graph of y equals s at x equals 2. That sentence here tells me to write a tangent line.
Okay, but how?
Okay, tell me the question so I can understand. How did I know?
How is this? Oh, never mind.
Well, I mean, we have a curve. We don't know how the curve looks, but we know that it behaves with this slope field, right? We don't know how the curve looks, but we know that we have an equation because we have a derivative. So we have some function. We don't know what the function is, but we're using that tangent line to approximate this function.
Okay. Oh, so what the equation that you just came up with, is that the tangent line or is that the actual?
That's the tangent line. That's not your actual. That's the tangent line at x equals 2. That's not the function. That's just a linear line. You know what I mean? Later on, we are going to find the actual equation. So this is my tangent line. I'm gonna leave it alone. So if I want f of 2.1, or do you guys want me to solve for y? Doesn't matter. Let's solve for y. Y minus 3 equals 9x minus 18 plus 3 plus 3. Y equals 9x minus 15. Is that correct, guys? Okay. Remember, Miss Taylor, I don't know, maybe you were getting confused by this. Your tangent line for values really close to where x equals wherever I got that tangent, it's going to be really close to the actual curve. Now, if you get a farther away from the tangent line, then it's going to be way off from the curve. But we can make approximations of your real value f as long as you're close to my tangent, where I got the tangent. Does that make sense? All right. F of 2.1 is approximately 9 times 2.1 minus 15. If you are scared, if you are scared about solving, about making a mistake, you can leave it alone right there. Are we scared? I hope not. No. Oh, if you're scared, leave it alone. If you're not scared, let's see if we can do this. 9 times 2.1. Well, 9 plus 9 is 18, and 0.1 plus 0.1 is 0.2, so that has to be 18.2 minus 15. I can do 18 minus 15. I'm confident about that. 15, 16, 17, 18. Isn't that 3? So then this must be 3.2. So I can write f of 2.1 is approximately 3.2. You see, I already made a mistake. I lost my point. 0.9 times 0.1 is 0.9. And 0.9 plus 0.9 is 1.8. And 18 plus 1.8 is 9. Oh, it's just 0.9. Why do I keep doubling it? Why am I doubling it? I don't understand why I'm doubling it. All right. Sorry, guys. 18.9. See, I would have lost my point. I would have lost the point. I'm not in the zone today. I don't know what's wrong with me. I'm in the sequences mentality, maybe. So here it is, finally, guys. We'll even look at the rubric to see if we got the full credit. 18.9 minus 15 is 3.9. So f of 2.1 is approximately 3.9. We'll check to see if we got all the points. 2016, remind me.
So when we look at this, the first thing is just that it wants us to write an equation. And so we just write an equation using the give us the slope they give us the new idea. And then we just use that and plug in the approximation.
Matter of fact, you could have even plugged in the 2.1 right here. 2.1 minus 0.2 is 0.1. 9 times 0.1 is 0.9. You know what? It might have been better doing it right there.
Okay, that makes sense. Yeah, I think I just read it and got lost because I didn't know if it looked like a particular solution.
No, well, that's not a particular solution.
Well, because it says let y equals f of x be a particular solution, and so I was confused.
Yeah, no, I mean, y equals f of x is a particular solution, but that is not my particular solution. That is just my tangent line. I'm using my tangent line to approximate my particular solution at 2.1. You know what I mean? Because if you find your tangent, as long as you're close to x equals 2, the y value is going to be pretty close. Now, letter C says to find that particular solution.
Okay, see, because I thought, yeah, so when I first read B, I was like, oh, it wants me to find a particular solution.
No.
Then okay.
Letter C does. Look at letter C. It says find a particular solution. Y equals f of x is a given differential equation with initial condition f of 2 equals 3. So right now, all I have is that dy dx equals, was it y squared over x minus 1? I think we have enough math skills to do this. You guys ready? For what do I do first? Rubio, focus, miss. Don't worry. If it's an emergency, you can go outside. All right, what do I do first, guys?
Not cross multiply, but group the different.
Group the x's with the x's, group the y's with the y's, separate. Keep the x minus 1 together. So here we go. Times, divide by y squared and then times dx. So I'm going to have this. dy over y squared equals dx over x minus 1. I'm going to rewrite it nicer. Oh, you know what? Am I going to have enough room? I think I should have enough room. 1 over y squared dy equals 1 over x minus 1 dx. Are we still okay? Oh, the variables are grouped by like y's. The y's with the y's. Oh, because that's a differential equation. And I have 2 different letters instead of just 1. You know what I mean? Okay, here we go. I'm going to rewrite this nicer. Y to the negative 2 dy equals 1 over x minus 1 dx. Are we still okay? I'm going to do the integral. What's the antiderivative of y to the negative 2? Perfect. Equals, what's the antiderivative of 1 over x minus 1? ln x minus 1, put absolute value, plus c. I think this is a good location to solve for C. We're no longer doing calculus. Now we're just doing algebra. What is my x value? What is my y value? So I'm going to have negative 1/3 equals ln, absolute value of 2 minus 1, close it, plus c. And you got to know a little bit of pre-cal, not much, or algebra, I guess. Negative 1/3 equals, what's ln of 1? 0. You don't have a calculator, so c is negative 1/3. So I'm going to rewrite it from here. Negative 1 over y equals ln, because I found now that I'm at position 2, 3, you can drop the parentheses, or the absolute values. X minus 1, close it, minus 1/3. Are we still okay, guys? All right. I'm kind of tempted to do common denominator, but I don't know. Are you guys okay with that? Or not, we don't have to. I haven't looked at the rubric yet. I'll see what answer they have. Can I do this? Can I do all that over 1? Yeah? Okay, sorry, because I'm scared of, I don't know how much algebra we know or not know. I mean, I do, but.
It makes sense that you could put that over 1 instead of 1.
Because I have on the left-hand side negative 1 over y, and I want to be lazy right now, so I just want to go, doot. It might not have that as a solution, but it's an answer. So here it is. Why did I do the over 1? Because I see that y, I see negative 1 over y. So side note, in case you're wondering, Chavez, I can't read your mind. What are you doing? Side note, a over b equals c over d is the same as b over a equals d over c. Does that make sense? So if I put this over 1, I can flip this and then just put a negative on the other side, and there I'm done. It might not have that as a solution, but we'll see. We'll see. So look, I'm gonna flip this. Negative y over 1 equals 1 over ln x minus 1 minus 1/3. Do you guys see that? And then I'm gonna get rid of that negative in the front. So times negative 1 times negative 1. So y equals negative in the front, 1 over ln x minus 1 minus 1/3. I like this answer. I do not know if College Board likes it. I mean, they'll kind of correct, but I do not know if this is the answer in the rubric. We're going to find out. I haven't seen it in like a year. I guess if we're trying to cheat the system, you can just leave it unboxed and let the reader find it. But you know, we don't want to cheat anyone, so you can box it. If you're confident boxing it, box it. Because we're not like, you know, we know calculus, so we're not trying to hack the exam. You know, like we know it. Okay. What year was this? 2016. So let's see, guys. Let's see how we did on this question. Calculus. College Board. Yeah, I'm very organized with my digital life. My digital life is organized. Scoring guidelines. Okay, what number was it? Okay, here it is. Did we get that? 2 points. Letter A. Letter B. Did we get tangent line approximation of 3.9?
Yes.
Yeah. Check it out. The equation for the tangent line is right there. Another 2 points. Letter C. Oh, look. They wrote our solution. Yay. I'm glad they did. All right. Look. 1 point for separation of variables. I think that is, as a matter of fact, I hope they give us one of these because it's one of the most generous rubrics in my opinion. They give you a point just for separating variables. I don't even think that's calculus. That's just like y's with y's, x's with x's. That's a point. 2 points for the correct antiderivative. Can you do the correct antiderivative? Negative 1 over y, ln absolute value of x minus 1. Plus c. 1 point for the constant of integration and uses initial condition. So that's a plus c with the 2, 3. Cool or not cool?
So why they put the 1/3 in front?
Oh, because of the negative. I'll show you right now what I mean. And then letter D solves for y. Guys, this is our equation. I know what you're saying, like, child, we didn't get that. No, it is. So notice that they put the 1/3 in front minus ln. So if I distribute the negative to this in the bottom, wouldn't that 1/3 turn positive and that doesn't turn negative? So they distributed the negative with the denominator, but it's the same answer. And this one, I remember, this one had like, I graded this one, I remember. This one had like 6 pages worth of possible solutions. Because a lot of students, you see how you have a fraction within a fraction? And in algebra, they scold that. They're like, oh, no, you cannot. And so they want, like, so a lot of, this one had a whole bunch of different answers that were correct that you could have gotten. But this is, in my opinion, the easiest one because it's the laziest one. The one that requires the least work. So we just put a 1 in the bottom, flip it, put a negative, done. It's correct algebra. Does that make sense to you guys? How do we feel?
Wait, the delta math, it was like, for the side note, for A and B,
Uh-huh.
a lot of like A and B together, so you like cross multiply. But for this one, so we need A and C together, so you just do A over C, B over D. Like that's like, okay, like you can do that.
Oh, A over C, B over D. Yeah, you can do that. But in this case, I just had this, so that's why I put a 1 down here, and I just go, toot. Like I just literally just.
Yeah, it's because I was, just for the delta, I was used to like the dy, and then the other y was like the denominator of the second one, so you just like group those and group like the other ones, but this one was like side to side to side. But like, okay, like
I think delta does u sub like differently also. I'm not a bit. Don't get me wrong. I love delta. But once there's specific topics that I don't like how they're doing it. I feel like they're starting to become like they're trying to make you guys robots. You know what I mean? But I get it. Like they're trying to teach everyone, and maybe sometimes the best way to teach everyone is just to have one uniform thing to tell everyone over and over again. I prefer to do critical thinking. You know what I mean? All right, guys. One last thing. Okay, I gotta detach this so I can show you. Let me stop. Okay, so look at this, guys, real quick. Oh, that one looks like a hard one. Okay, well, I guess we'll do a hard one. I didn't want to do a hard one off the bat, but that's fine. It says, the slope field for the given differential equation shown below, sketch a solution curve that passes through the point 3, 1. So there's my point, 3, 1, and it looks pretty funny. Let's see if I can do it. So it looks like, for sure, you see how these are practically vertical? So it looks like it goes like that. And then let's see, it's going to go like that. And what's happening here? Trying to follow it. Let's see. It's going down. And then it's going up. It's going up right here. So how is it going? Like that? And like that? Okay, so it looks like it doesn't have to be perfect. You'll see. And it looks like that. I may be wrong. I hope not. Hey, it was almost right. It was almost right. Look, it's this that tripped me up, but it was almost right. Do you guys see that? So I think the variance is too far away, and now they're like, no, that's too far away. But it doesn't have to be perfect. Look, let's do another one. That's not as hard. Okay, this one looks like it's easier. So it is delicate. So it looks like it's going like that. And then that one looks like that. There it is. See? So, and look, it doesn't have to be perfect. See, look how off my graph was. See? But I did notice that it was very sensitive with that point. So even if your curve looked more or less like that, but it didn't go through that point, you're going to get that error message that says, didn't go through the point. That makes sense, guys? And look, and that's what I'm doing it with a mouse. So if you have a scratch pad, it's going to probably be hard to do it with a little trackpad. But if you have a touchscreen, it might be easier through the touchscreen, maybe. Does that make sense or no?